class. At first, we need to review what we have learned last time. And last class, we have learned two questions. The first one, we have learned what is the civil engineering. Yet, we have a lot of pictures about what is the building and what the building engineering and the development of the building engineering. Okay. And then we have about the bridge. The bridge engineering and the road engineering and the hydraulic engineering. They are all belong to the civil engineering. All belong to the civil engineering. And from this kind of structures, we can find many kinds of different materials, civil engineering materials. In these materials, we can find the aggregates, the cement, and concrete, steel, and asphalt, and asphalt. And for this kind of civil engineering materials, the first one we have learned is about the cement. The cement is the most widely used materials in civil engineering, because if we want to build a house, if we want to construct a road, a bridge, a dam, we need to use these kinds of materials. This is the cement. It is the most widely used in the civil engineering. And the second is about the aggregate. The aggregate maybe consists of two kinds. The first one is come from the nature. So we call it the natural aggregate. The second one is the man-made aggregate. And for this kind of aggregate, we can divide them into two kinds. First one is coarse aggregate. And for this one, it belongs to fine aggregate. It's fine aggregate. The function of these two kinds of aggregate is different. The first one for the coarse aggregate is the skeleton. The skeleton or frame. Skeleton or frame of the concrete. And then the fine aggregate is for the density of the concrete. And the amount of the aggregate is the biggest, because we can use the cement concrete for the house. We can use the asphalt concrete for the road. In the cement concrete or in the asphalt concrete, the percentage or the dosage or the content of the aggregate is the biggest. Maybe in the cement concrete, maybe 80 or 90% of the materials in concrete is the aggregate. So the amount of the aggregate is the biggest. And then for the steel, maybe it is just invented for about 200 years, but it is very important for the size, for the performance, for the lifespan of the structure. Right now, it is always used with the cement concrete. or the cement. Maybe we want the reinforced concrete, reinforced. And then is for the asphalt and asphalt concrete. The application of the asphalt or asphalt concrete is more widening now. We can use the asphalt concrete for the road, to construct the road for the construction. And then we can use the asphalt for the waterproof of the structure or the road, for the waterproof of the structure of the road. And for the asphalt, there are two kinds of state for the asphalt. The first one is the solid one, But when we study the asphalt, there is one condition we must mention. What kind of condition? For the asphalt, temperature. Yes, temperature. Because if the temperature is up, it is softened. It will be softened. Okay, and then if the temperature is down, it will be crisp. It will be harder. I don't want to be harder. And this is the liquid one. This liquid asphalt is mainly for the waterproof of the structure. And this solid asphalt is mainly for the asphalt concrete for the road. Asphalt concrete for the road. So this is that. What we have learned last time, two questions. And then we have learned something about the history of the materials. What is developed? And from the stone, wood, and then the stone and the wood all belong to the natural materials. So in the ancient time, if we want to build a house, if we want to build construct a road, we need to use this kind of natural materials. And then we can use this modern materials now, including the concrete, the steel. The history of this concrete and the steel are all about 200 years. And for the natural materials such as the stone, the wood, and then for some man-made materials such as the bricks, yeah, is about the history of the bricks in about 2,000 years. And for the concrete and steel, it's just 200 years. 200 years. And we can consider that the application of these kinds of materials will very, very long. Maybe several hundred years later, maybe 2,000 years later, we all need to use these kinds of materials for the civil engineering structures. Okay, and the glass and the fiber in the modern, and these kinds of materials make the structure more strengthened, more comfortable, and the life of the structure is also and the materials of about the engineering quality of the materials. The first one is about the beauty, and the economy. We need to control the cost of the materials and the engineering structures. And then the safety, and durability. Durability is related to the lifespan of the materials of structure and flexibility. If a kind of material is popular for us, it is most important that this kind of materials can be used conveniently. This kind of materials can be used conveniently. So this is about the applicability. So we have there are some new materials, new technologies for them. And for the definition and classification, we have mentioned last time. The first one, if we want to divide them by the chemical compounds, by the function, and by the location. If by the chemical compound, we can divide the materials into three types. The first step is inorganic. The second one is organic. The third one is composite. In inorganic materials, what kinds of materials we can learn belong to the inorganic materials, such as the glass, the steel, cement, concrete, rocks, also the aggregates. They are all bricks, yes. They are all belong to the inorganic materials. And what kind of materials belong to the organic materials?
Wood.
Such as the wood, asphalt, rubber,
Plastic.
plastic. And then for the composite materials, it all consists of two kinds of materials. So this is for the classification of the materials by the chemical compounds. And then we can get the classification of the materials by function. The first one is the load bearing materials. In our classroom, the beam, the column, the slab, the floor, they are all belong to the load bearing materials. And in this class, there are some enclosing materials, also decorative materials, such as the tile, the painting, they are all belong to the decorative materials, also enclosing materials. And by the location, there are different kinds of materials we can divide. So, and for the history and the trends, we have just remembered. But the most important thing I want to mention or emphasize is about the steel and the concrete. We have just learned that the history of the steel and the concrete is very short. It's very short, just 200 years. And then, in the future, we need to use these kinds of materials for a long time. And for the trend, what we need in our future. So the materials need to develop like this trend. The first one, most important, is high performance, including the strength, including the life, including the durability, the durability, and then multifunction, and environmental protection, and the energy saving. So this is the trend. Maybe in the future, we need to emphasize. So from now on, we have found that there are three kinds of materials developed in our history. The first one is the man-made materials, just like the bricks, the bricks. The second one is steel. The third one is the concrete, including the cement concrete, asphalt concrete, and so on. So maybe several hundred years later, maybe there are the fourth materials. And for the fourth materials, it is need to consider this kind of chain. It needs to be high performance, long durability, and multifunction, and energy saving, and the environment protection. It needs to be considered for the consideration. And about this cost, what do we need to do for this cost? The first one, we need to get some basic knowledge about these kinds of materials, including the cement, the concrete, the aggregate, the asphalt, the steel, the asphalt concrete. We need to get some basic knowledge about them. What is the basic knowledge? Including the composition of these materials, including the produce of this kind of materials, raw materials of this kind of materials, and then the performance of these materials, and the testing, evaluation, application of this kind of materials. So this is about the basic knowledge for our study. And then you need to get some basic skill. What is skill? For the experiment. Maybe we need to do this next year. And then select the right material. Select the right material for many thousand available ones. From many thousand. We need to know if we want to build a house, what kinds of materials we need to choose. We need to select. For example, the cement. There are many kinds of cement. What kind of cement we can use for this building? What kinds of steel we can use for the building? Yeah? So this is first one is the basic knowledge, and then is for the selection of the materials. And provide background for the other special courses. Because in future or before you leave from the school, you need to learn a lot of courses. And for this kind of courses, the civil engineering materials is the basic for them. So, what is about the contents of this course? Maybe till now we can make it clear. The first one, we need to get some concepts of civil engineering materials. In this part, we need to study this kind of concepts. This kind of specs is suitable for the cement, for the concrete, for the aggregate, for the asphalt. So they are all have this kind of concepts. And then we need to study some special or important materials. First one is inorganic bending materials. In this part, we need to study three kinds of inorganic bending materials. The first one is the lime, the second one is the gypsum, the third one is the most important one, cement. In this part, we should study these three kinds of inorganic bending materials. And then we'll study the aggregate. And then the concrete. In this part, especially the cement concrete, we will study this part. And then for the structural skills, and then last one is about the asphalt bundles, asphalt bunding, and asphalt mixtures. So this is about the contents of the course. So, what we should do? What should we study? The most important is these three parts. The first one is about the property of the materials. The second one is about the application of the materials. And then maybe we need to do something about the modification or the improvement, of this kind of materials. We get to meet the raw materials, production, composite, structure, standard, test, and so on. And in the application, we get the specification, such as the test, about the materials, about the construction. There are a lot of specifications, So, thank you. I'm going to for this course. Okay, maybe we can get a score of the final. So the most important, I should emphasize about the class. Everyone needs to enter the class in time, and then listen to it. And for some discussion, some kind of discussion. Okay. Okay, this is about the introduction of our course. And then we'll move on to the chapter 2. In this chapter, or in this part, we are studying a lot of concepts about the civil engineering materials. It is suitable for the aggregate. It is also suitable for the cement, also for the asphalt. So these kinds of concepts are all the basic ones. So in this concept, the first one we need to know is about the physical properties. If we learn something about the physical properties, maybe in nature, we need to study the mechanical property. Yeah, this is a physical property. Mechanical property. In the physical properties, there are several different concepts we need to study. The first one is about the density. And then we need to know for the density, it is very simple because we have learned it before. But in our course, in this course, if we mentioned about the density, it means there are several different kinds of density. The first one is the apparent density. And then there is the bulk density. And then loose density or the consensus density. And then the solidity and cross porosity. In this course, we are emphasized on these four kinds of density, and the porosity, four kinds of density and porosity. So the first one is about density. The formula about density is very simple. Yes? For the density of materials, the formula of it is just like this. It means that it refers to the mass. Yes, this is the mass per unit volume. Per unit volume. When the materials are in the, I need to emphasize on this. The state is not in the natural state. It must be in the absolute dense state. Absolute dense state. And this we can get the density of this kind of material. But we need to know for most of the materials, including the rock, aggregate, including the cement, concrete, most of these kind of materials are they in the absolute dense state? Are they in the absolute dense state? No. Just for example, the aggregate or the rock. Is it absolute dense? It is in the absolute dense state? No. There are pores in it. Maybe we can't find it by our eyes, but the pores exist in it. So, for this density, it must emphasize on the absolute dense state. Absolute.
If you say absolute density, what is an absolute density?
What is the absolute density? You mean?
The absolute.
There is no pores. Pore. P-O-R-E. Pore? Yeah, there is no pore in this kind of material. We mentioned it. The absolute dense state. Absolute. For example, this chalk. Is there any pores in it? No. Is there any pores in it?
Yes.
Yes or no?
Yes.
Yes, there are a lot of pores in it. If it is absolute dense state, it will be like a rock. You mean? There are what is consist of? Powder. Yes? Powder, a lot of powder. And then compress it. But there are a lot of pores in it, still in it. So, for most of the materials, there are pores in it. How about that? Cement? You mean cement? Okay. What is cement? Do you know something about it? In the cement? Okay, first of all, you need to know what is cement. Cement is a kind of powder. Yes. And then when we put the water into it, it will react. And after the reaction, the strength of the cement is developed. It will be hardened. So maybe you want to know, after the hardening, is the cement or the hardened cement is in absolute dense state? No. There are still a lot of cracks and pores. What you want to know what is the absolute dense state? Yes, it's just kind of emitting state. Emitting state. It is not really exist in the nature. For example, the wood is not absolute dense state. Yeah. For the rock, is also not absolute dense state. You need how to find the apple. Yes, maybe just maybe this kind of diamond. So in the nature, most of them are all not in the absolute dense state, especially for our construction materials. In what kind of? So this is the first one for the density. So the second one, if we want to get the absolute dense state, we need to grind it. Grind it. For example, the chalk is made consist of the powder. Yeah, we need to grind it and more finer, more finer. But why we need to grind it? We need to be separate. We need to get the pores out of it. Yes, get the pores out of it, and get the absolute dense state of the powder. So this is first kind of density. First kind of density. We can call it the real density. If we want to know other kind of density, we need to know this diagram. In this diagram, maybe this is in the natural state, the volume of a material. In the material, maybe the volume of it is divided into three parts. The first one is the solid. Yeah, the first one is the solid. This is in the absolute dense state. The solid. However, besides the solid state, there are many pores. And this kind of pores also can be divided into two parts or two kinds. The first one is just like this one. Yeah, the next one. They all belong the core. They are the core. Permeable pores. Permeable pores. However, for this one, they belong to the impermeable pores. For the permeable pores, it means that it contacts with the air. Clear? It can contact with the air. But for the impermeable pores, it is inside the material. So for any kind of materials, we considered the volume of the material consists of three parts. One is the solid. The second one is the impermeable pores. The third one is the permeable pores. Okay. If the material is in the absolute dense state, maybe this part, these two parts is disappear. And just have the solid. So for the second density is the apparent density. Is the apparent density. The apparent density means it refers to the mass per unit volume, still unit volume. But this volume is different for the, it is different to the absolute dense state. Absolute. And the volume is of the impermeable portion. So in this one, for this volume, it has two parts. The first one is a solid volume. Solid volume. The second one is the impermeable porous volume. The volume for the impermeable pores. Impermeable pores. So this is the second one. The third one. No. Okay. The PPT well, I have given them to the office. Okay, you can get this material from the office. Okay, you can ask them to give you this kind of. So this is the apparent density. The most for this kind of several different density. The difference is just like in this. It's just like in the volume. So the third one is the bulk density. Bulk density. In civil engineering, this density, this kind of bulk density is the most popular for us. I always use this kind of density for the inspection, for the evaluation, for the test of the material. It means that under natural status, if we mention it is in the natural status, we need to know the volume of the material consists of three parts. Yeah, the first thing is the solid parts, and the impermeable part, and the permeable part. So in natural state, we can get the bulk density of the material, So, and now we have studied what is the three kinds of density. I need to give you a question. For the same material, for example, I give you a rock. For the rock, it has these three kinds of density. What is my question? I want to know which one is the biggest. They are not in the same, yeah? Also for the one core, for the one rock, for the same rock, the density, apparent density, and the bulk density is different. So I want to know which one is the biggest, which one is the smallest. Which one is the biggest? The first one. Yeah? Because for this one, the formula is just like this. This volume is the solid volume. Yeah? And then for this one is like this. It's including the volume of the impermeable pores. And for this one is including another one in the impermeable pores volume. Yeah. So from this side to this side, the density is decreased. It decreased. Is decreased. So this is bulk density. Bulk density. About these three kinds of density. Besides these three kinds of density, there are still the force. The force. The force density. So what is the force density? We call them the loose grain, for the loose grain materials. For loose grain materials. What is loose grain materials? Okay, maybe explain it just like this. if I give you if I give you a rock, one rock. For this rock, we can calculate the density, apparent density, and bulk density of it. Yes, three kinds of density. But if I give you a pack of rocks, there are many rocks, yeah? And then we can get the matrix, because if this is a rock, for the volume of this rock, maybe there are three parts, yes? There are three parts. One is the solid volume. One is the volume of the solid. And then the volume of the impermeable pores. And then the third one is the permeable pores. So just for one pore, yes, for one rock. But I give you a pack of rock. You know what, like this. Yeah? So, in this volume, there is a new state occurs. Where it is? Between, yeah? Between the rocks. There is the void. There is the void. Just like this. Yeah? This is one rock. This is another rock. Separate rock. But between them, there are voids in the state. So, if we consider the materials in this parts, like this, put them together, we can get a lot of voids between them. And then we can get the density. This density we call it the loss density. And for this volume, how many parts in it? For this volume. For this volume, how many parts in it? 4 parts. 4 parts. Yeah? The first one is the solid parts. And then the impermeable parts. And void. So, when get to know that what is the velocity density. Okay? There is a question I need to mention. What is it? For the same rock, for the same kind of rock, we have just learned that for the first three kinds of density, this one is the biggest. Yeah? This one is the smallest. So my question is, when the nose density compared with these three, how about it?
Also because
It would be much bigger or smaller? Smaller. It would be much smaller. When you compare with these three. These three. So this is about the nose density of them. Okay, we can take a look. All kinds of density. This is the density, the curve density, and the part density, and the nose density. We need to get the difference between them. We need to get the difference. And this one video not porosity. So what is the porosity? The porosity means the proportion. The proportion of force volume to the volume of the material. So this is the porosity. And from what we have learned last just before, what we have learned, we need to know this porosity is consists of two parts. The first one is about the permeable pores. The second one is about the impermeable pores. So, what is the formula of it? This is the porosity. This is the what kind of volume? What kind of volume? Absolute steady state. What is this volume? Natural, yes, as a natural state, So, this is the relationship between the porosity and volume. So, how about the porosity, the relationship between the porosity and the density? We find that the porosity is related to the, what is this density? The real density. Yes, the real density. What is this real density? It is also related to this volume, the bulk density. Yes, bulk density. But this porosity consists of two parts. I need to just say. The first one is about the permeable porosity. And another one is the impermeable porosity. You do not need to write it. Okay, maybe next week we can get our textbook, and then you can get the PPT well. So maybe the most important thing you need to listen. Okay? This is about the porosity. Okay. So we need to get the summary about the pores. Because we have just mentioned, for the construction materials, what is the civil engineering materials? It is hard for them to get the absolute dense state. What does this mean? It means that there are some or a lot of pores in this kind of materials. So how how about the pores affect the performance of the material? So this is the pores and their volume, their influence. The classification of the pores. Classification. The first one is the connected pore. Connected. This is the connected. Yeah, connected pore. And another one is the closed pore. So what does this mean? Because, for example, I give you a piece of concrete, okay? In this piece of concrete, we have learned there are a lot of pores in it. Yeah, there are a lot of pores in it. There are a lot of pores in it. But in these pores, some of them are connected. How to connect them? How to connect the pores? By what? By what? To connect the pores by what? Cracks. Yeah, cracks. The cracks connect the pores. You want to become them compatible. But for this separate ones, they are belong to the closed pore. They belong to the closed pore. And then coarse pore. What is coarse pore? What is fine pore? What is micro pore? It all relates to what? Relates to what of the pores? What is the coarse pore? Fine pore. Related to the size. Yes? To the size of the pore. If the size of the pore is big, it belongs to the coarse pore. It is small, the fine pore. And between them is micro. Pore. So this is about the classification. And then we just have studied the physical property. Yeah, physical property. And then in this section, we need to know something about the mechanical property of materials. Mechanical properties. Maybe when I mention the mechanical property, what maybe you can consider, or what maybe you can think about. What is the mechanical property? For example, maybe we can think about the strength. We can think about the what? Displacement and the deformation. Yes, deformation. Because if we get a load for materials, we don't want the deformation will occur. Deformation will happen. So, in the mechanical property of materials, there are three concepts. There are three concepts or three parts we need to know. The first one is about the strength. The strength is the most important mechanical property for all materials. For wood, for steel, for cement, for concrete, for rock, the strength is the most important mechanical property for them. And then the deformation property, which means that how the material changes after loading, under loading. And then it's about the breakage and toughness. So what we need to know, what is breakage? What is toughness? Toughness. The first one is about strength. Do you still remember how to calculate the strength of the? How to calculate the strength? Do you still remember the formula? Maybe maybe environment like this. Okay? This is strength. What is at the bottom of it? Area. Yeah? Area. What is this? Force. Yes? Which means that the force per unit area, we can get the strength. Strength. So, for strength means that the capacity of material to resist breakage by the external force. External force means the outside load. Outside load. So, the first one we need to know the definition of the strength. It means the capacity of material to resist breakage by the external load. If the loading is big enough, the material will be broken. So, for the strength classification, it can be divided into two kinds of strength. The first one is the static strength. So, what is static strength? If we maybe next year we need to do some experiments about the construction material. Maybe in one of them is the strength test. Is the strength test of concrete. For the strength of the concrete, it is belong to the static strength. Because in the lab, when we want to do the strength experiment, we need to get the machine, to conduct the load on the material. For example, on the concrete specimen, But the accelerate, the velocity of the strength is slowly. We conduct the load slowly on the specimen. When we get the strength, just like this, we can get the static strength. And what is the dynamic strength? The dynamic strength means we conduct the load on the material in a very, very short time. But for the static strength, we conduct the load on the specimen slowly. Conduct the load slowly. But for the dynamic strength, we conduct the load just like this one. This dynamic strength. This is static strength. Right there. So they are different. For the same specimen, they are different. So, based on the stress caused by loads, strength is divided into several different types. The first one is compressive strength. So, what is compressive strength? We conduct a compressive load. Conduct a compressive load. And then we can get a compressive strength. And we get a tension. We get tensile strength. And then the shear. What is the shear? How the load was conducted? The shear. The shear. Two specimen. For the compressive tensile strength, just one specimen. But for shell, two specimen. This is one specimen. This is another specimen. But there is a contact area between them. Yeah. Two specimen. Yeah, just like this. And then this is the shell. There is a force. And then to make them displacement, to make a displacement for them, we can get the shear strength between the area. Yeah. Friction. You mean friction? No. This is not friction. Friction like this. Yeah. Friction like this. But for the spaceman, maybe I just make a mistake. This is just one spaceman. One spaceman. But the force is not in the same line. You mean that? This is the force, like this, and force like this. They are not in the same line. And then the spaceman need to be split, just like splitting. Like this. So we can get it. Shear stress. And then, if we put a force maybe at the center of the spaceman, we can get it will be bending. So we can get bending stress on the. So there is another question we need to think about. For the same materials, for the same kind of material, for example, for the concrete, okay? Did you find that? The beam is constructed by the concrete, yes? The beam. For this beam, it can get its compressive strength, yes? It can get its tensile strength, it can get its shear strength, and it can get its bending strength. For the same kind of concrete, these four kinds of strengths are different. Okay? For the concrete, which kind of strength is the biggest? For the concrete, which kind of strength is biggest? Which one? Tensile? Tension? No. The tension is much lower. Very lower. Which one is the biggest? Compressive. This is the most important advantage for the concrete. The compressive strength is biggest. Biggest. Okay. For example, for one kind of concrete, compressive strength of it maybe 50. This is the compressive strength. But for the same kind of concrete, the tensile strength or tension strength is just 5 micro. So it is much smaller than the compressive. But for the steel, the tensile strength is very, very high. Yeah? For the steel, the tensile strength is very high. So this is the diagrams of materials under load. The first one is the compression. Under compression, we can get its compressive strength. Yeah, we need to know how much is the load, and then how about the area, and then for the tension strength, we can for tension, and this is bending. This is bending. The bending, maybe we can have two kinds of methods to test the bending strength of the material. The first one, we put the force at the center. At the center. Yeah, this is the specimen. At the center of the specimen, we can get to the bending strength of it. And then we divided the force into two parts. And the place we conduct the load, we conduct the force, the place is also different. Maybe at the divided the specimen into three parts, and then put the force at this part, at this section, Okay, this is shell. Yeah, this is shell. This is the specimen and the force. But they are not
The same line.
in the same line. Yeah, if they are in the same line, it will become the compressive. Yeah, compressive. So the shell will act as this section. So this is about the strength and the different parts of strength. So, what is the strength grade? What is strength grade? For example, for cement, we need to have different strength grade. What? For example, the cement, maybe, first one I need to explain what is the strength grade of cement. It's just some number, yeah? Just some number. 32.5, 42.5, 52.5. It's just numbers. So what does this number mean? What does this number mean? The strength. What kind of strength? We have just said the cement, the concrete. What kind of strength? Compressive strength. Yeah, compressive strength. But we have know something about the strength of the cement or concrete. After we mix the cement with the water, is there strength? After we mix the cement and the water, is there any strength?
Yes.
Is there any strength? Just after the mixing. No, it's floating. It's flowing. Yeah, it is flowing. So there is no strength. But where is the strength come from? It comes from the reaction of cement and water. But it needs time. Maybe 1 day later, 3 days later, 1 week later, yeah, the strength will be increased. So, what does this number mean? It means compressive strength. But we just mentioned the strength of the cement or concrete is developed. Yeah, is developed. The strength after 1 day, the strength after 1 week is different. So, what does this number? It means after 28 days. Okay? After 28 days, maybe probably 28 days, 4 weeks. Yeah? 4 weeks. Yeah? 4 weeks. After 4 weeks, the compressive strength of the cement is up to 32.5, we call it 32.5 grade. If it's up to 52.5, we call the 52.5 grade. So, according to the compressive and bending strength, compressive and bending strength, but this number means the compressive strength, So,
those numbers are only when the reaction takes place, the reaction with cement and the water. Are they only when the reaction takes place, then they increase, like it increases from something to 32.5. That number is about because of the reaction of water and
yeah, cement.
Okay.
Okay. So another question we need to know: why? Why we need to get this different kinds of cement grade? Why? Why we need to get these different grades? Because just for the application of the cement. Yeah? If we just want to build a house for myself, okay, this is one. Another one is we need to get for high building. They all need to use cement. Yeah? But the cement used for me or used for him, it's different. Yeah? Because if the building is high, the strength of the cement must be higher. Yeah, must be higher. So for the different fields or for the different construction structures, we need to divide them, the cement, into different grades, as well as the concrete. Yeah, if we want to construct a bridge, we want to construct a road or build a building. The concrete, the strength of the concrete for these three kinds of structure is different. And therefore steel also, the strength is different. Fragility is different. Okay, this is for concrete. For the concrete. So we just mentioned for the cement, the strength grade, the numbers of the strength, the number of the strength grade means the compressive strength after 28 days or after 4 weeks. So this is the grade, strength grade of concrete. Okay. Are you get the difference of the cement and concrete? Are you get the difference between the cement and concrete? Yeah. The cement is just one kind of product we can get from the plant. Yes. And then it is one of the raw materials for the concrete. We need to put the cement, the aggregate, the ultra, maybe some other admixture together and mixing them, and then we can get concrete. So, for the concrete, this is the grade of them. C15, C20, C25, till C80. So what is C means? What is C means?
Cement.
The same is concrete. Yeah. Say means concrete. The first means concrete. So what does this number means? It also refers to the compressive strength after 28 days of concrete. This is of cement, yeah? This is of concrete. So, this is about the strength grade of the
I wanted to ask.
Mhm.
So, like, you said for concrete, after 28 days, if it's C20 or that's the strength according to the compressive. Oh, that's the grade
Mhm.
according to the compressive strength. But my question is, what is that figure dependent on?
What is what?
The number? Okay, this number is 32.7.
Like the numbers can be increased.
Okay, yeah, 32.5 plus 2.52. What is it dependent on? Like, is it that I know it's a period of 20, I need to maybe make like a mixture of cement and water, right? And then I have to wait for it I have to put it aside for 28 days, is what you said? Then after that 28 days, is it that it will just decide on its own? Is it that when mixing, I need to put an amount of cement for it to be 52.5, or I need, or any amount of cement,
Like what kind of like
amount?
do we need amount of cement that can be 42.5 or 52.5?
You mean what amount?
Like, do we need a specific amount of cement? Like when you mix the cement with water,
Yes.
after 28
After
days,
28
it's
days.
supposed to be at a certain figure for you to know the strength grade, right? It's supposed to be either 32.5, 42.5,
52.5.
yes, 52 and the like. But then is it that when mixing the cement and the water, are you given specific figures for you
No.
for you to know? So you can,
No.
the cement has to choose on its own.
Yes, your question is about if I get this 52.5 cement.
How am I supposed to know that I'm going to get 52.5? Like if I want to build a house and my house is supposed to be very strong, am I supposed to get an amount of cement? Am I supposed to mix an amount of cement with water for me to know that I want 52.5? I want the strength grade to 52.5. So I should mix an amount of cement with water, or you can just mix anything.
I know.
Yeah, you can just.
You mean that if I want to get higher strength,
Yes. Am I supposed to do this?
if I just increase the amount of the cement, can I get the high strength of concrete? No. No. Okay. Because we need to know for cement, if the percentage, the strength grade of cement is 52.5, we can get the strength of the concrete. Maybe you can think is bigger than the 52.5, or lower the 52.5. If I use this grade cement, yeah. If I use 52.5 strength grade cement for the concrete, the strength of the concrete will lower than the 52.5. Why? Why? Okay. I'll explain it to you. Maybe we are studying this part later, but I need to explain that first. Okay? This is in the This is the concrete specimen. Okay? In this part, in this specimen, What is this?
Steel.
What is this? Aggregate. Yeah? Especially the coarse aggregate. Yes? And then what is this? The hardened cement. Yeah? After the reaction of the cement on the water, it will be hardened. Yes? This part is the hardened cement paste. So, if we conduct a load, compressive load, it will be broken. So, how it will be broken? Maybe there are 3 kinds of breaking. The first one, the crack. Split the aggregate. The first one, yeah. The second one, the cracks develop cross the cement paste, hardened cement paste. Okay, this is the second one. The third one, the cracks contact the aggregate surface and then developed along the surface of the aggregate and then contact another aggregate and then develop along the surface of the aggregate and then broken. Which one? The first one is splitting the aggregate. The second one is across the hardened paste, cement paste. The third one is along the surface of the aggregate. Which one?
Second one.
The third one. Why? Why? Because in this diagram, there are 3 kinds of splits in it. The first split is what? The split of aggregate. Yeah? If the crack splits the aggregate, it means that the aggregate broken. Yeah? So the first is the split of aggregate. The second one is the split of hardened cement paste. Where is the split come from? The hardened cement paste? It comes from the split grade. The third one is there. So for these 3 kinds of splits, which one is the smaller list? Which one is the smaller list? The aggregate strength, the cement paste strength, or the surface strength? Which one? Which one? The third one. The third one. Yes, the third one. Because compatible is compatible with the aggregate and cement paste. This is the paste, this is the paste, yeah? This is the aggregate. The surface between them is much weak. It's very weak. It's very weak. It's very weak. So the crack will develop. So for the concrete, the strength will decrease. This will mean that if you want to get C40 grade of concrete, okay? If you want to get C40, you cannot use 32.5 grade cement. Okay? If we want to get 30-40, say 40 of concrete, if we want to get say 40 of concrete, you cannot use 32.5. Maybe you just increase the amount of cement. No, it cannot. It cannot get 40. Say 40%. Okay? You have some question?
So which one I have to use for C40?
You mean?
I want to make a C40.
Say 40, okay?
So which grade
Which you mean which you need to select? Which grade? Maybe the most, the best, you need to get this one. Use this one. This one maybe is not very good.
Lower.
Yes, because they are very, very close.
So there is only CC 2.5 grade cement, but I have C80. So how can I make?
You mean get C80? You may want to get C80? Okay, the first one you need to use this one. Okay? And then you need to use a lot of admixture. Yes, admixture. Just like the skeleton powder, and plasticine, and the hardened admixture. Yeah. If you want get this so high.
Some engineer said admixture is not good for concrete. So
What it is?
if I use admixture with concrete,
Okay.
in the, after some years, the concrete stage will cross. Concrete will be failed.
Okay. You mean that if we use some admixture for concrete, but maybe after some years later, is that admixture to harm to the concrete?
Right.
Oh, okay. No. It is not harmful. If it is harmful for the, it relates to the durability. Okay, durability of concrete. So if you choose one or two admixture, you must consider it. You must consider it the durability.
And sometimes we use admixture in concrete for long time binding. Because, I mean, I want to carry concrete to long distance.
Long distance.
Yeah,
I want to get
that's why I have to mix some admixture. Because if I don't use any admixture, my concrete will be compressed, and I won't able to use this concrete for make building. So that time I use some admixture. So what would the effect these kinds of admixture?
Okay. You mean that if you want to make a long distance concrete, yeah?
No. I have to carry from. I mean, I have to build a building here, but I have to bring concrete from Central City because that is.
Oh, you mean that the transportation?
Yeah,
The transportation. Yes, you mean that? Yes.
For the transportation,
Because
sometimes we use some admixture.
if
So
the distance is very long,
yeah.
you must add admixture.
Yes. What is the effect of these kinds of admixture?
What one?
This admixture is good for concrete or no?
Yes. So what is good for concrete? The first one is the admixture can keep the flowing properly. Flowing properly, you mean after the mixture of the concrete, it can flow. It can flow. Yes, it can flow. So the first one, the admixture can keep the flow. And then the admixture can accelerate the development of skills. And after some years, the author not to have to. Yeah. So the admixture we must select carefully. We must select carefully. And most of them are not to harm not to harm for the performance of the country. Okay? Okay. Today is for this. Okay, let's break.
Maybe class is over.
What?
Class is over.
Yeah, it's class over.
This class is very interesting for us.
Yeah, ready? Okay.
You can love see.